Hello, welcome back. We got a short lecture for you today. Should follow right along the same process that we did yesterday with arc length. Now we're going to, instead of applying it to the circumference or distance around the circle, now we're going to apply it to the area. So the way that we derive this formula, which you could actually just totally do it yourself, is the same way we would answer this question. So here's a scenario. The other day, I ordered a large pizza to split it with my friend. Now, he wasn't very hungry, and I hadn't eaten anything all day, so I ended up eating 6 slices of pizza, 6 out of 10 of this large pizza. Now, if the large pizza, large one-topping pizza, has 3,000 calories, then how many calories did I end up eating? So the way that you go about answering that question, which is a very real question if you're logging your calories for nutrition or something like that, or for a diet, that's a very simple question that you would need to know how to answer, and I'm very confident you guys know how to do it. In coming up with our answer, we're actually kind of deriving the formula for sector area. So to find the area of any sector of a circle. So what we're going to end up doing is writing the formula for the area of a sector. So A sub S is going to be equal to the fraction of the whole thing times the number of calories that are in the whole thing, or the area of the whole thing, which is how we'll be doing it in a second. So if there are 3,000 calories in the whole, what fraction of the pizza did I eat? So I told you I ate 6 slices out of the 10 slices, which is more than half, right? 60% of the pizza. So I would write the fraction as 6 out of 10 multiplied by the whole thing, which is 3,000. So what's 6 tenths out of 3,000? So I can multiply that. So 6 divided by 10, and I can put it in as a fraction if I want. So 6 tenths, and I'm going to multiply that times 3,000, which gives me 1,800 calories. Now, considering I'm only supposed to eat 2,400 calories in a day, I just ate 75% of my daily amount of calories in one sitting. Now, that's how I roll. I don't know about you, but sometimes I eat like one meal a day, which is probably not healthy. But when I do eat, man, I put away food. So apparently 1,800 calories worth of food. It was really good. No regrets. I'm going to take advantage of my metabolism. I don't know how I keep my figure. Anyway, moving on. All right, so that's essentially how we derive the formula for a sector area. So if we want to find the area of this pizza, let's say that has a radius of 6 inches. So the area is pi times the radius squared. So if the radius is 6 inches, we're going to do 6 squared, which would give us 36 pi. So our area is 36 pi inches. Now keep in mind, pi is an irrational number. So if we want this as a decimal, we'd actually have to put it in as 36 pi and then convert it, and it'll give it to us as a decimal, which is about 113 inches squared, or square inches. Now I like to leave it just as 36 pi. That way it has all the full precision of pi, right? So it's exactly 36 pi. Now, if we wrote 113 square inches, that would be an approximation. Okay, so that's area. So what if we want to find not the area of the entire pizza, but the sector area, the area of this sector, which is the blue region right here? Well, we start out exactly the same, and we end up with this whole fraction of a whole formula. So our radius, again, would be 6, and then so the area is 6 squared, which would be 36 pi. Again, I'm going to leave it in terms of pi because it makes the numbers nice and easy. I don't have to round anything. So how do you find the area of the sector? Well, you probably would just look at this and say, okay, well, that's a quarter section, right? That's a fourth of the whole pie. You can see those fractions really easily, right? So how would we write the equation? Well, the fraction of the whole thing would be 1/4 of the 36 pi, right? So what's 36 pi divided by 4? So 36, we can put it in the calculator. I guess I'll go ahead and show you how to do that. So fraction button, 1/4, 1/4 of 36, and I'm going to put pi with the pi button there, and that'll give me 9 pi. Now, if you're using your phone or a calculator that doesn't leave it in terms of pi like this, then just leave pi out of the equation. So if I do the same thing, and I just do 1/4 times 36, and notice I just leave the pi out, it's going to give me just 9, right? And then add the pi into it at the end. Because some of your calculators, when they give you 9 pi, they will only give you the decimal approximation without leaving it in terms of pi. So just a way that you can get around that, which is kind of nice to know. So our answer would be a fourth of 36, which is 9 pi. So this is 9 pi inches squared. So what is our formula for the area of any sector? Well, the fraction is going to be the central angle, the number of degrees out of the full 360 degree from the circle of oughtness. So that would be x degrees divided by, I am stuck in that accent, 360. So that's our fraction, and then multiply by the whole, which would be from our formula for the area, which is pi times the radius squared. So pi r squared. So this is the formula for the sector, or the area of any sector, which should just make sense. It's just some fraction of the whole thing. All right, so now we want to do 120 degrees of this whole pizza. This is a smaller pizza with only a 3-inch radius. I hope you're not hungry, because all these pizza looks really good. So radius is 3 inches. 3 squared would be 9 pi, right? And so what's our fraction? Well, 120 out of 360, which is 1/3, right? Times the 9 pi, which was the whole thing. So what's a third of 9? Well, that's going to be 3 pi. And we can also put it in the calculator if we're not sure. So we have 120 out of 360, and then we're going to multiply that by 9. I'm just going to leave the pi out and put it in my answer, so it would be 3 pi. Now, if you can't put the fraction in your calculator, you can also just put it in like this. So 120 divided by 360, and then we're going to multiply it times 9, which gives us 3. So exactly the same thing. Alrighty. Moving on. Oh, that was it. So whole lecture in 7 minutes. That's what I'm talking about. So very similar to yesterday, so it didn't take very long. So you'll get out your assignment. We're going to go ahead and go through these problems together. The last 2 problems are pretty cool. We're going to talk about darts and pizza, and which size pizza at Papa John's is the best value. I know, I'm so excited. It's going to be really cool. All right, so number 1, we want to find the area of the shaded region. So I shaded mine with the blue lines there, but yours are just shaded gray. Yeah, I'm looking at the assignment. Okay, so should be good to go. They tell us that the radius is 4, so what's the area of the whole thing? So radius is 4, so 4 squared is going to give us 16 pi. So the whole thing is 16 pi. We want to find the area of the sector. Okay, this one's 90 degrees, so it's obviously a quarter section. So what's a fourth of 16? You can probably do that in your head, but if you want to see how to set it up, what's our fraction? It's going to be 90 out of 360, which reduces to 1/4, right? Times 16 pi, and then we can put that in the calculator if we're not sure. So I'm going to do 90 divided by 360 multiplied by 16, which will give us 4. So our answer is 4 pi, because I just left the pi out to leave it in my answer. So if it's there, it's going to be there as well. All right, so the answer would be 4 pi. All right, number 4. So for the sector area for the central angle, we have to add them together. So 90 plus 45 is going to be 135 degrees out of 360, which is the fraction 3/8. So if we put that in the calculator, I'm just going to do 135 divided by 360, and it's going to be 0.375. So that's a decimal if you're used to using standard units, such as like the empirical units with inches, like 3/8 of an inch or something, then you're kind of used to that fraction. But anyway, it doesn't really matter. All right, so we want 3/8 of the whole thing. Well, the radius is 2. That tells us that the area has to be 2 squared, which is 4 pi. So what's 3/8 of 4? Okay, so we do 3/8 multiplied by 4 pi, which would give us 1.5 pi. So our answer is 1.5 pi. 3/8 of 4 pi is 1.5 pi. All right, so number 10. In a circle, a 60-degree sector has an area of 24 pi feet squared. So we want to first find the area of the circle, then we can solve for the radius, and then we can solve for the circumference. So this problem is pretty tricky because we're working backwards. We're used to having the radius and the sector, the central angle for the sector to be able to solve for the area of the sector. But now we have the area of the sector, and the central angle, and we're trying to solve for the radius. So we're working backwards, but we set up the formula exactly the same. We're just solving for a different variable in this case. So the first thing we want to solve for is the area of the circle. But I need you guys to be able to not just work in one direction, but be able to work backwards and manipulate formulas to solve for different variables. You guys are in honors, so I expect you to be able to do some of this stuff. And I'm pretty sure there's going to be some problems like this on the test. So anyway, our fraction is 60 out of 360, which you might know as 1/6. If you don't, that's okay. Multiplied by the area. Now that's what we're trying to solve for, so I'm just going to leave it as a capital A. That'll be like our x or our variable in this case. It's going to be equal to, they told us the sector area was 24 pi feet squared. So 1/6 of the area is 24 pi. So then what is the whole area? So what I need to do is I need to get rid of this fraction. Well, how do we undo, now these are being multiplied, right? We're multiplying this by a coefficient, which is a fraction. So how do we undo a fraction? We multiply by its reciprocal, right? Which would be dividing it by 60 and multiplying it by 360. So let me show you what that looks like real quick. So I'm going to duplicate this and then flip them. All right, so what I'm going to end up doing is multiplying both sides by 360 and dividing both sides by 60, and that's going to be what and if I do it to one side, I got to do it to the other side as well. Alrighty, so hey, not bad. I totally cheated. That's the only way I can draw straight lines. Straight is relative. You're welcome, third hour, all you who are listening. All right, so we multiply by the reciprocal. We do the same thing on the other side. So 24 times 360 divided by 60, which this is actually, if that was 1/6, the reciprocal of 1/6 is just going to be 6. So we just end up multiplying it by 6, but that's okay. Let me show you how we do. So we do 24 times 360 divided by 60, which will give us 144. So the area is equal to 144. So I'm going to go ahead and show that right here. All right, now that we know the area of the whole thing, we can find the radius. So the area is equal to pi times radius squared, which is 144 pi. So if we divide both sides, we got to solve for the radius, right? If we divide both sides by pi, then we're just simply left with, so those, when we divide both sides, they reduce to 1. So we're left with the radius squared is equal to 144. So we take the square root of the radius squared and the square root of 144, which is going to give us 12, right? So radius is equal to 12 inches. There we go. All right, now that we know the radius, we can now solve for the circumference. So circumference is 2 times pi times radius. So it's not pi r squared, it's 2 pi r. So 2 times 12 would be 24 pi. So notice all the work we did. It wasn't that bad. We just set up our equations and solved for the missing variable. But we were working backwards, so it's a little annoying. Also, I could give you the circumference and then ask you for the radius and then the area. So we could work the other way too. All right, number 11. We want to find the area of the shaded region, and they want us to leave our answers in terms of pi. So if you just leave it out of the calculator and tack it into your answer at the end, that's how I do it. All right, so on this one, we have a square, and then inscribed in the square is the circle. We want to know the difference between the area of the square and the area of the circle, which is actually kind of a cool problem. So we're going to solve this by deconstruction. So first thing we want to do is find the area of the square. So 6 times 6 is going to be 36, okay? And then from that, we're going to take away the area of the circle. So 36 minus that. All right, now to find the area of the circle, we need to know what its radius is going to be. Well, on this one, our diameter is 6, right? That's the width of the circle. So that means that our radius is going to be 3 meters, right? So 3 squared is going to give us 9 pi. So we're going to do 36 minus 9 pi. So 36 minus 9. And I want to actually put pi in here because my answer, wait, they said leave it in terms of pi. Let me take a look real quick at the answer bank. Yeah, this one I don't want you to leave it in terms of pi, because if we wrote it as an expression of pi, we'd have to leave it as 36 minus 9 pi, unless we factored out the 9, but don't do that. So anyway, on this one, actually, to change it to a decimal, we would get 7.72, which would round to 7.73, which is what it says on the answer bank. So what is the area of the shaded region in meters squared, which would be 7.73 approximately. So this is approximately equal to 7.73 meters squared. So ignore this part because I didn't put the answer bank in terms of pi. I changed it to a decimal. All right, number 15. So we're on the back side now. I like this problem. And you're going to have a problem like this one on the test as well. So make sure you know how to do it. So we want to find the area of the flower bed. So we have a circular fountain. I'll go ahead and read it. A circular fountain is surrounded by flowers. The fountain's diameter is 8 feet. So the radius would be 4, right? The flowers extend 1.5 feet from all directions from the fountain in all directions. What's the area of the smaller circle, the base of the fountain? So we want to find this green circle's area here. So 4 squared would be 16 pi. All right, next thing we want to do is find the area of the whole thing. So if we take the 4 and we add the 1.5 to it, that would give us an entire radius of 5.5. So how do you find the area of the big circle? Well, we need to square 5.5. That one's not going to be that easy because we have a decimal, so I just put it in the calculator. So 5.5 times 5.5, or 5.5 squared, is 30.25. So the big circle is 30.25 pi. So then how do we find the area of the flowers? We got the inside region, which is the fountain. We got the whole thing, so we take the whole thing minus the fountain. So that's 30.25 minus 16 pi. So 30.25 minus 16, both those are in terms of pi, so our answer would be 14.25 pi. Now let me show you what I just did. Okay, so 30.25 pi minus 16 pi is going to be equal to, let me see if I can change it to a decimal. Ah, nice. Yeah, good discussion here. All right, so because it was multiplying by a decimal, it wanted to keep it in terms of a decimal, and then when I try to convert it back, it gives it as a fraction. So I'm a little bit weird because I prefer the decimal and the pi button and the pi. Here, the calculator wants to give it as a precise fraction and pi. But 57/4 is not as easy to understand for us with fractions to understand that is equal to 14.25. So 14.25 pi has the precision and hopefully the understanding of what that value might be precisely. So it's precisely in terms of pi, and we have a decimal instead of a fraction. So what I would do in order to get that answer is I would just simply leave the pi out of what we put in the calculator. So I would do 30.25 minus 16, which would give me the 14.25, and then just add the pi to it at the very end. So I think some of the confusion on this in this unit is just when you leave it in terms of pi and when you don't. That's kind of determined what the question asks or what your answers are in the form of, and then how you put that in the calculator in order to get it into that format.